Control line flying. It's fun, exciting, and perhaps the easiest way to get started in the fascinating hobby of model aviation. The control line or U-control model is a lot less expensive than one using radio control and doesn't demand the wide open spaces needed for free flight. Therefore, control line fields can prove easier to reach for younger modelers, and the comparatively lower cost makes them attractive to everyone. But before you're ready to slow your carrier model down to a hover or fly precision aerobatics, you need to master the basics of control line model building and flying. It's easier than you might think, and by following the suggestions offered in this video, your skills will develop quickly. There's something truly special about creating a flying model from nothing more than a couple of sheets of balsa and perhaps a few sticks. To get you started in this exciting hobby, the SIG Half-A Skyray is an excellent choice. Not only is it easy to build, but its large wing area and light weight make it an excellent flyer. We chose the Half-A size as a starter model because of its low cost and economical operation. One of the little Cox engines will provide a whole lot of flying on a quart of fuel. There's no landing gear on the Skyray, and this makes it ideal for flying over the proverbial soft grass to protect it somewhat for those inevitable crashes destined to be a part of any learn-to-fly process. No expensive tools are necessary to build the Skyray, but there are a few basics you should have. No matter what model airplane you eventually build, you will need a modeling knife, and the old standby X-Acto No. 1 handle with the No. 11 blade is hard to beat. In addition, you will need a few sheets of sandpaper for shaping and smoothing balsa wood. 100 grit is coarse enough for most rough shaping, while 220 grit will work to smooth out your work. A much finer grit, such as 320 or 400, will help you get a smoother finish on your Skyray. The first step to building the Skyray, as with any kit, is to familiarize yourself with the components and the construction plans. Begin by laying out all of the components so that you can get an idea of what they look like and compare them to the plans. Notice that the Skyray is a straightforward design with few parts. It's always hard to take the extra time needed to study a set of plans when you're chomping at the bit to begin construction, but it is time well spent. As you gain experience, you will learn that most kits require certain construction steps to be followed in sequence. Failure to follow that sequence can result in having to cut away areas already assembled in order to finish constructing the model. Once you have an understanding of the construction steps and the components involved, begin construction by cutting out all parts. The wing is a good place to start. The Skyray wing is printed on a sheet of 1/8-inch medium-weight balsa. Note that the location of the bell crank, lead-outs, and other components are also printed directly on the wing for ease of positioning. Cut the wing out of the balsa sheet using a modeling knife with a new sharp blade. It's always a good idea to begin construction of a new model by using a fresh blade in your knife. A single-edge razor blade can also be used to cut out the parts, but a modeling knife is far superior in both ease of cutting and safety. Always use a straight edge whenever possible to assure that your cuts are straight and square, and always protect the part with the straight edge. That way, if the knife should slip, it will go harmlessly into the scrap and not damage the part. Use a series of passes, and never try to make the cut in one pass. Cuts that follow a curve are normally done freehand. Again, take a series of passes with your knife, making each one deeper than the previous cut. Note the direction the wood's grain runs. If your knife slips, it will naturally follow the direction of the grain. Cut in a direction that will lead the knife away from the part if it should happen to slip. You'll also find cutting to be easier in this direction. Cutting across the grain can be difficult, particularly with thicker, harder sheets of balsa. Once you get much beyond 3/16 inch thick, you will be better off using a jeweler's or jigsaw. But for all practical purposes, the Skyray wing can be cut out with an ordinary hobby knife. Once the wing has been separated from its balsa sheet, the rough edges of the cut can be dressed up with a sanding block. The other balsa components of the half-A Skyray are die cut and easier to remove from their balsa sheet. Even the best die cutting seldom cuts all the way through the balsa, so do not try to simply punch out the parts. Instead, lightly sand the back of the sheet to help free the parts. Then use your modeling knife to finish the separation. The rudder is offset 1/4 inch. You can accomplish this by blocking up the trailing edge of the rudder with a piece of 1/4 inch thick scrap. Note, however, how this causes a gap between the rudder and the fin. Remedy this by blocking up the trailing edge of the rudder and holding it flush with the edge of your building board. Next, using a sanding block, sand the edge that will mate to the fin until the sanding block is parallel with the building board. The resulting angle will allow you to have a flush joint between the fin and the rudder. This gives you more gluing surface, making for a much stronger and neater appearing joint. Glue the rudder and fin together with medium viscosity CA adhesive. Remember, CA adhesives can bond skin instantly, so be careful. Parental guidance is strongly recommended for younger modelers if CA is used. SIG bond is a safer and dependable alternative to CA. However, if you are careful, CA is an excellent adhesive for most modeling applications. If you do manage to stick your fingers together or end up with a Skyray for a finger ornament, don't panic. CA solvents should solve the problem. Always read and follow the safety instructions printed on the label of any adhesive. Even though CA sets up quickly, it's still a good idea to give it a little extra time before working with the piece. While waiting, use your sanding block to round the leading and trailing edge of the stabilizer. Then round the leading edge of the elevator and sand its trailing edge to a slight taper. Your Skyray will fly without all of this sanding and shaping, but it will fly even better if you take the time to at least round all of the edges. This shaping gives the model a more streamlined shape and therefore less wind resistance. It also removes extra balsa, making for a lighter airplane. Although the thin wing of the half-A Skyray doesn't allow for much airfoil, every little bit helps, and this extra shaping will increase performance. Once the stab and elevator have been sanded, cut the cloth hinges into 1-inch squares. Attach them using SIG bond or other aliphatic adhesive to both the elevator and stab. Begin by pinning the pieces of cloth in position, gluing one hinge to the stab, the next to the elevator, and so forth. Use your finger to spread the glue, but be careful not to get the glue onto the hinge area. Flip both pieces over and repeat the process. This time, the hinge that was glued to the elevator goes to the stab, and vice versa, until both pieces are connected. After drying, the elevator should now swing up and down smoothly. By now, the rudder assembly should be dry enough to sand. Round off all the edges except where they will attach to another part of the model. Next, the wing can be sanded to shape. It is not really necessary to sand to an airfoil shape, but it can add that extra bit of improved performance to your model. Do not round off the wing edges where it attaches to the fuselage. The fuselage is shaped also, but be sure you leave the stabilizer platform flat. Once you have all of the surfaces sanded to shape, sand them carefully with a finer grit paper such as 220. This will smooth out the balsa. It is now time to begin assembling your Skyray. Attach the wing first using a square to check alignment with the fuselage. It is also a good idea to measure the distance from the tip of the wing to the tip of the nose to assure proper alignment in this direction. Then once you are satisfied with the alignment, run medium viscosity CA along the joint. Capillary action will draw the adhesive into the crack where it will quickly set, forming a solid joint. A fillet of cement can be run along any crack that might exist between the fuselage and wing. Medium viscosity CA or SIG bond will work. Next, glue the cheek blocks to the fuselage, making sure they are flush with the nose. To obtain the strength necessary for any components holding an engine, use epoxy glue for this construction step. The firewall is then removed from the die-cut plywood sheet. Smooth it up with a sanding block and epoxy into place. When you are certain the epoxy is properly set, use a modeling knife and sandpaper to shape the nose blocks. The bell crank is attached to the wing before the stabilizer is glued to the fuselage in order to obtain the proper bell crank to control horn distance. This is necessary because of the preformed push rod. By supplying the push rod already formed, SIG eliminates the wire bending stage that many beginners find difficult. Once the bearing, control horn, and washer are cut away from the bell crank, use a modeling knife to trim the top inside edge of the bell crank pivot hole. This is necessary to let the bearing rotate freely. During control system installation, always keep in mind that a good flying model needs a smoothly operating control system. Install the bell crank by gluing the plywood bell crank mount to the top of the wing. Proper location is easy since the mount is outlined directly on the wing. Then sand the wing's surface enough to eliminate the black markings. If you use a light-colored dope to finish your model, these markings could show through unless you have done some sanding. Use the screw provided to screw the bell crank onto its mount. Don't over-tighten the screw or you will have a stiff bell crank movement. Leaving the screw too loose will result in a sloppy movement. The control horn is now attached to the elevator using the small wood screw and washer provided. Now insert one end of the push rod into the bell crank and the other into the control horn. Pin the bell crank into a neutral position. Next, slide the stabilizer forward or backward on the fuselage until the elevator is in a level or neutral position. Once this is done, pin the elevator to the fuselage and check it for alignment. Alignment is very important in model airplane construction. It can mean the difference between a good flying model and one that is a real dog. The stabilizer assembly should be parallel with the wing. Many modelers do this by simply eyeballing the alignment by holding the model at eye level and sighting down the front of the fuselage. Major discrepancies can be seen and corrected. Serious builders will go a step further by propping the model up on a flat surface and checking alignment with a ruler. The distance from tip to table should be equal on both sides, as should the distance from wing tip to stabilizer tip. This last measurement assumes you align the wing properly by measuring the distance from tip to fuselage nose. All of this might seem like a lot of extra work for your first half-A model, but developing good construction habits now will make building that Super 35 powered stunt ship a lot easier later on. When you are certain the stabilizer's alignment is satisfactory, glue it in place with CA. The rudder fin assembly is now glued onto the fuselage. Again, check alignment. Remember, the rudder is offset 1/4 of an inch to help keep the control lines tight when flying. With everything in place, remove the control system hardware and you are ready to paint. Before painting, smooth the entire model with number 300 grit sandpaper. Brush off the balsa dust, or better yet, use a tack rag available at most any hardware or paint store. The first coats on your new model should be clear dope. While it can be used full strength, it is much better to thin it 50-50 for better penetration and easier brushing. Even though the Skyray is not a large model, you can still use a fairly wide brush. A good 3/4 inch camel hair brush will work just fine and can be purchased either at your hobby shop or any good art or hardware store. Try to flow the dope on from a fairly full brush, working in the direction of the wood grain. Don't go back over previously doped areas, as dope dries rather quickly. and the tacky dope will pull the bristles from your brush. The unhappy result can be a model that looks like it's wearing a fur coat. After each coat of dope, flex the elevator to make sure it still works freely. Too much dope buildup in the hinge area can cause stiffness, but this flexing between coats will keep this to a minimum. Even though dope dries quickly, let the model set for at least an hour before sanding. Then, using a 300 grit paper, sand lightly following the wood grain. After sanding, it's a good idea to wipe the model once again with the tack rag to remove any dust. Then give the sky ray a second coat, following the same procedure as the first. Adding color dope to your model is where the fun begins. You can follow the picture on the kit box and paint your model with SIG Super Coat, sky blue, color dope, or let your imagination and artistic ability run wild. It's your model, and the choice is up to you. Whatever color you choose, thin the dope by adding 1 part thinner to 2 parts color dope. This will work well for brushing. If you have access to a spray gun, thin the dope 50-50. SIG has made it easy to trim your sky ray by supplying a set of stick-tight decals. These self-adhesive decals are easily trimmed apart using a sharp pair of scissors or knife. Cut close to the image, leaving about a 1/16 of an inch clear edge around the decal. We prefer to use the wet method of application, which allows the modeler to move the decal after it has been set on the model surface. After peeling the decal from the paper backing, soak it in a bowl of warm water for a few minutes. Using a soft brush, dip the bristles into the water and then spritz it with the Windex or Fantastic brand cleaner. Brush this solution onto the area you want to apply your decal. This soapy solution will prevent the decal from sticking to the model until you have it positioned exactly where you want it. Once it's where you want it, dab a soft cloth over the decal to absorb the excess water and begin to smooth the decal down, squeezing out any remaining air bubbles or excess soapy water from under the decal. You may also use a soft scrap of balsa to squeegee the decal. Allow the decals to dry overnight, and when completely dry, wash off any soap smears with a clean, wet rag. Once the airplane has been decorated and trimmed, attach the lead-out wires to the bell crank. Insert the brass lead-out eyelets into the lead-out guide and reassemble the control system. If you are a beginner, put the push rod into the inside hole on the bell crank and the outside hole on the control horn to limit elevator travel. When attaching the lead-outs to the bell crank, do not make the loops too small, or you may cause binding, causing a stiff control system. Make certain you put the lead-outs through the guide at the wingtip before forming loops on the end of each. Also make certain that the bell crank is in the neutral position when you form the loops, and that each loop is even with the other. If not, you will have more control in one direction than the other. Form the loops in the lead-outs using a pair of round-nose pliers. Twist the free ends tightly and smear on a bit of epoxy for extra strength. You will need a bit of weight on the outboard wing to offset the weight of the control system and lines, and 2 pennies epoxied to the underside of the wingtip will be just about right. You are now ready to mount the engine, and the integral tank supplied with the Cox 049 makes this quite easy. Just attach it to the firewall with the sheet metal screws supplied with the kit. Use 2 flat washers between the engine and the firewall on the left side to offset the engine to the right. This will help keep the lines tight while flying, and that's what we're going to do next. Before we begin flying our half-A Skyray, and since this model has the control system out in the open, let's take a look at how your actions in the center of the circle cause the plane to climb, dive, and perform aerobatics. The main components on the model are the bell crank, push rod, and the control horn. The bell crank is connected to the flying lines and ultimately the control handle by two wires called lead-outs. The bell crank is basically a mechanical device that converts the up and down movement of the control handle to up and down elevator. Note that as you pull on the up line, it pulls the rear of the bell crank toward you, causing the bell crank to exert a pushing force on the push rod. The push rod in turn pushes against the control horn, which raises the elevator into an up position. This will cause the airplane to climb. Pulling on the down line has the opposite effect, as the front of the bell crank is pulled toward the pilot, causing it to pull the push rod, which in turn pulls the control horn, causing the model to dive. Once you understand how the control system works, it's time to head out to the flying field and put this knowledge to work. Performing a few pre-flight chores before starting your engine will do a lot to ensure a fun, crash-free flight. Begin by carefully rolling your lines off the reel from the airplane's position to the center of the circle. Never uncoil the lines off the side of the reel, as you are just asking for kinked lines, and kinked lines can break, causing an accident nobody needs. Half-A models can be flown using Dacron flying lines, and many pilots do just that. Lightweight 008 or 012 wire lines, however, have the advantage of creating less drag. For this reason, serious half-A flyers usually choose wire. Be careful, though, because the lightweight wire can kink easily. Connect the lines to the model, making certain that the up line is connected to the up lead-out and the down to the down. Then, with your pit crew holding the model, walk your lines to check for twists and kinks. When you reach the handle, raise it from the ground and allow it to spin out any twists that may have occurred. While at the center of the circle, check the controls to make sure they're hooked up properly and working freely. Pull the handle back and watch for your crew to signal up. Do the same for down, and again watch for his signal. It's also a good idea to put the handle into the neutral position and have your crew check this also. Most control handles are adjustable and could have been adjusted for another model with its lead-out wires unequal in length. Once you are satisfied that everything is in order, it's time to fire up the engine and fly. The best way to learn to fly control line is with an instructor. This can be anyone with enough experience to help you start your engine and be in the circle with you in case of problems.
Got all that down? You ready to try one?
Yeah.
Okay, well, we'll just go out and I'll stay with you. And
The hobby shop where you bought your model will be more than happy to recommend someone. After all, it's to their advantage to have you become an experienced model builder and pilot. Starting a model airplane engine is fairly easy, but you do need to maintain a certain amount of safety precautions. The prop can give you a nasty whack if it hits you. And while you will not be the first modeler in history to suffer this mishap, you will not enjoy it. The larger engines hit even harder, so it's important to develop good habits now. Fortunately, the Cox Black Widow engine we are using has a spring-type recoil starter. This will make things a whole lot easier. All you need do is follow the simple instructions supplied with your engine, and you should have it running in no time. But before you start the engine, check the wind direction. The model is most vulnerable to the wind during the first few seconds of your flight, and if it is blown in toward you, the lines will become slack and you will lose control. It is best to take off with the wind slightly behind the model, so that it will be climbing out with the wind helping to hold the lines tight. This will give you full control during a critical part of the flight. Once you have determined your takeoff point, have your helper hold the model securely while you start the engine. With the engine running, go to the center of the circle, pick up the handle, and check that you have it upright. When you are satisfied, signal for your helper to release the model. If your helper is inexperienced, his first tendency will be to throw the model. Don't do this. The Skyray will fly out of his hands with a gentle push needed at most. He should be careful not to point the nose in toward the center of the circle. Pointing it slightly outside will guard against this. As the plane is released, you should have the controls in neutral, and be careful not to over-control. Remember, over-control is the cause of most crashes for beginners. A good way to guard against over-control is to use the forearm to control the airplane rather than wrist movement. When you raise your arm, the airplane will climb, and when you lower it, it will dive. Wrist action will accomplish the same thing, but it will be jerkier and can easily cause you to over-control. Take it easy on your first flights and concentrate on flying smooth and level, slightly above shoulder height. Maintain this level flight until the engine quits, and then glide the model with the nose slightly down until it is just about ready to land. Then flare out with a bit of up, and you have completed your first control line flight. Don't become discouraged if your first flight was a bit ragged or even if you crash. Now is the time to begin practicing climbs and dives. Begin your first climbs with the wind at your back. Raise your arms slightly and the airplane will climb gradually. Level off by neutralizing the controls when the lines stretch upward in an angle of about 45 degrees. Fly a couple of laps at this altitude, and then with the wind again at your back, lower your forearm slightly, causing the model to dive. Level off at about shoulder height, fly a couple of laps, and repeat the procedure. Once you have mastered shallow climbs and dives, begin to increase their angle until you feel comfortable performing climbs and dives that are nearly vertical. Then for your first real maneuver, try a loop. The inside loop is accomplished by applying moderate up control from level flight and then increasing this control as the model begins to fly over on its back. The reason for this is to allow the model to gain altitude during the climb portion of the loop and then to pull out with safe room between it and the ground on the dive side. As you gain experience and confidence, you will begin to round out your loops so that you exit at the same altitude at which you entered. In the beginning, however, it is best to allow yourself a safety margin. Let's repeat the procedure. Enter the loop with the wind at your back to keep the lines tight. Begin by applying a moderate amount of up control to allow the model to gain a safe altitude before it goes over on its back. Then increase the amount of up so that it pulls out at a safe altitude. Your first loops will be anything but round, but with practice you will learn how to fly the model through the maneuver in order to achieve a nice round loop. Your half-A Skyray is capable of more maneuvers, such as outside loops and inverted flight, but these will be much more fun with the 35 version. So now that you are a competent flyer with the half-A Skyray, it's time to step up to the thrill of a full-size 35-powered control line model. Half-A is fun, but once you experience the maneuverability of a larger model and feel the firm tug it has on your lines, you will be hooked on control line flying for life. For our 35-powered ship, we have chosen our Skyray's big brother, the Skyray 35. Like all of SIG's kits, this control line model has just about everything included except engine, wheels, tank, prop, and fuel. So there will be very little you need to buy beyond the kit. For power, we have chosen the venerable Fox 35, a proven engine that has given control line flyers dependable service for over 40 years. Flying this combination will prepare you to specialize in other more advanced areas of control line flying and provide plenty of